Yo, Code Pilots! Welcome to part 2 of the Python Masterclass, Data Structures. Last time, we introduced the basics, and now we're diving into arrays. If you missed the Python and OOP basics, check the playlist link. Let's get started. Let's talk about what arrays are. An array is a linear data structure that stores elements of the same type in contiguous memory locations. This makes accessing elements by index fast, but it has limits like fixed size in some languages. In Python, we use lists as a flexible version of arrays. This episode explores their concepts and how to implement them. Let's dig in. Why are arrays important? They're the foundation for many data structures and algorithms. For example, in a game, an array can hold player scores, and searching or sorting relies on them. Python's lists act like dynamic arrays, growing as needed, which we'll see in action. We're using Jupyter Notebook to make this interactive. Let's start coding. In a new Jupyter cell, type myArray equals 10, 20, 30, 40, and run it with Shift-Enter. This is a basic array using a Python list. Add print myArray. You'll see 10, 20, 30, 40. This shows how we can store data sequentially. Let's break down how indexing works. Try print myArray 1 for 20. Let's add and modify elements. In a new cell, use myArray.append 50 to add 50 and run. Then print myArray shows 10, 20, 30, 40, 50. To change an element, try myArray 0 equals 5 and print again. Now it's 5, 20, 30, 40, 50. This flexibility is a Python list feature. Let's discuss its implications. Now, let's explore limitations. Add myArray 5 equals 60 and run. It errors because we're out of bounds. Unlike static arrays in C, Python lists handle this by resizing, but accessing invalid indices fails. This shows a trade-off. Let's compare it with a fixed size approach using NumPy. Import NumPy as np, fixed array, equals np array 1, 2, 3. Let's try a function to work with arrays. In a new cell, type def sum array. Total equals 0. For num in R, total plus equals num. Return total. Print sum array myArray. Run it. Output is 195. 5 plus 20 plus 30 plus 40 plus 50. This simple algorithm sums elements, showing how arrays support operations. Let's analyze its logic. To wrap up, we've covered what arrays are, their implementation with Python lists, and a basic function. We saw flexibility with lists and a glimpse of NumPy for fixed arrays. This sets the stage for stacks and queues next. Arrays are a starting point for more complex structures. Let's prepare for the journey ahead. That's it for part 2, Code Pilots. You've learned about arrays and coded them. Like this, subscribe, and practice with lists and the sum function. Next time, we'll explore stacks. See you then, and keep coding.